Today, we're going to explore something pretty wild: how the incredibly powerful AI that's now literally living inside our phones is being used to solve one of the world's biggest, grittiest, and honestly most invisible problems: industrial waste.
All right, so here's how we're going to break this down. First, we need to understand the sheer scale of the waste crisis. Then, we'll look at the brilliant digital solution that's been created. After that, we'll dive into the magic of on-device AI that makes it all possible, meet the actual piece of hardware that pulls it all together, and finally, zoom out to see the brand new data-driven economy this whole thing creates.
So, our journey doesn't start in some slick data center or a clean lab. Nope, it starts with a massive industrial challenge that's pretty much hiding in plain sight.
To really get a sense of the scale here, just look at Canada. Every single year, the country generates a staggering 4 million tons of waste just from construction, renovation, and demolition. That is a mountain of trash, and we are quite literally running out of places to put it.
Now, here's the real kicker. All that construction waste could be super valuable. It could be feedstock for the new green bioeconomy, but there's a huge disconnect. What you get from a job site is a chaotic, wet, messy pile of junk, contaminated with all sorts of stuff. What the bioeconomy needs, though, is material that's pure, dry, and perfectly sorted. It's a total quality mismatch.
And you know, this isn't some problem for our grandkids to solve. The clock is ticking, and fast. In Ontario, a series of deadlines is creating what the industry is calling the capacity cliff. By 2029, you won't even be allowed to put this wood in a landfill. And by 2034, there just won't be any landfill space left. The whole system is staring at a total collapse. So, you've got this 4 million ton problem and a ticking clock. How on earth do you solve a sorting problem that big at an industrial scale? Well, the solution is a really cool concept called a digital refinery. Now, it's not a physical building, it's an intelligent software system that acts like a sentient bridge, connecting the messy world of waste with the super precise needs of the bioeconomy.
And this refinery works in 5 distinct layers. It starts with AI right at the point of collection, the edge. Then it manages all the complex logistics. It plugs directly into government regulatory systems like Ontario's RPRA through APIs. It even handles a whole new way of billing. And finally, it provides rock-solid, verifiable reports that you can use for things like carbon credits.
Okay, that all sounds amazing, right? But here's the million-dollar question. This entire super smart, data-heavy system depends on a critical decision that has to be made in less than 2 seconds. Often on a muddy job site or in a basement with absolutely zero cell service. How is that even possible? The answer lies in maybe the most important tech shift happening right now. We're moving AI out of the cloud and putting it directly on the device you hold in your hand. We're putting the brain inside the machine.
And the difference is just night and day. Cloud AI is powerful, sure, but it's slow, it has latency, and it needs internet. On-device AI, on the other hand, is instant. It works anywhere, and it's completely private. For the Digital Refineries app, which has to make these critical compliance decisions on the spot, this isn't a nice to have, it is absolutely non-negotiable.
The secret sauce that actually makes this work is a piece of Google software called LightRT. The best way to think about it is like a high-performance engine, specifically built to run these new, super powerful AI models right there on the edge, on a phone, without ever needing to call home to a server. And the speed we're talking about is it's staggering. Just look at the difference here. Running an AI model on a phone's normal CPU versus its specialized GPU. LightRT lets you tap into that GPU, and the initial processing, what they call prefill, is almost 8 times faster. Out on that muddy job site, that's what zero latency actually feels like. It's instant. Okay, so we've got the problem, we have the concept for the solution, and we have the software engine. But you still need a field agent, right? A physical device that can actually run this whole operation from the palm of your hand.
And this is where the story gets really wild. Enter the Google Pixel 10 Pro. It's a regular consumer phone, but its specs are, almost by accident, perfectly designed for this incredibly demanding industrial job. We're talking the Tensor G5 chip, 16 gigs of RAM, and Android 16 with the Gemini Nano V3 model built right in.
But it's not just the raw power. It's how all the features come together that makes it the perfect tool. Gemini Nano V3 isn't just about text. It's multimodal, meaning it can see and understand images, text, and speech all at once. There's a proactive feature called Magic Queue that actually anticipates what the user needs, and the whole system is designed from the ground up to work offline.
And the performance you get on this device is just incredible. Gemini Nano V3 can process text from an image at 940 tokens per second. In human terms, that is effectively instant. It lets the apps take a photo of a woodpile, analyze it, classify it, and check it against all the government regulations in way under that 2-second requirement.
So we've connected a smartphone to a pile of industrial trash. Pretty cool. But let's zoom all the way out because we need to understand why this is such a huge, fundamental shift.
This really gets to the heart of it. The digital refinery, powered by that little AI in the phone, doesn't just sort wood. It performs a kind of modern alchemy. It transforms a physical liability, a pile of trash that you have to pay to get rid of, into a verified, trusted, and valuable data asset.
And that data verification unlocks a completely new business model: waste as a service. The product isn't just hauling anymore. The product is a guaranteed, verifiable stream of clean material. And that data trail is what gives companies access to the high-value bioeconomy and those lucrative carbon credit markets.
So what's the big takeaway here? Well, this whole thing is really a blueprint for the future. It shows us that on-device AI is graduating from being a fun little novelty to becoming critical infrastructure. It proves that the consumer tech we all carry around can solve really gritty, heavy industrial problems. And most importantly, it shows that the real magic is turning physical liabilities into financial assets through data verification.
And this leaves us with one last really big thought. If a smartphone can be the brain for an industrial waste refinery, what other complex, hidden, absolutely essential parts of our world are about to be completely reinvented by the AI in your pocket?